Bun găsit la emisiunea Știință și Cunoaștere! Astăzi continuăm difuzarea interviului îngrijorător cu matematiciana și astrofiziciana Valentina Zharkova, cercetătoare la Universitatea Northumbria din Marea Britanie. Data trecută am prezentat elementele de bază necesare înțelegerii mecanismelor dinamului solar, iar acum veți afla consecințele îngrijorătoare ale descoperirilor doamnei cercetător Valentina Zharkova, acreditate în revista Nature. Spuneam data trecută faptul că cercetătorii climei rareori acordă atenție influenței Soarelui asupra climei terestre, ei fiind focalizați mai ales pe influențele antropice și eventual ale altor factori naturali din atmosferă, litosferă și hidrosferă. Altfel spus, oceanele, solul, apele, care sunt implicate în marile circuite climatice. Însă, o altă categorie de cercetători s-au specializat pe studiul Soarelui, iar aceștia sunt astrofizicienii și matematicienii. În partea a doua a interviului cu matematiciana și astrofiziciana Valentina Zharkova, cercetătoare la Universitatea Northumbria din Marea Britanie, veți afla care au fost consecințele descoperirilor sale, cum au fost ele primite de comunitatea științifică și ce putem face pentru a ne adapta unui asemenea scenariu climatic dacă se va produce. From all the science and logic you have, is there any chance at all that some other Earth climate component could counteract against this solar influence and delay the cooling time frame further a little more? Maybe some long ago stored heat in the oceans to rise up and continue to warm the continents?
Oh, definitely. Whatever planet does, I'm no specialist in planetary temperature. It will be a changing of direction of Gulf Stream, for example, around Great Britain. If a Gulf Stream moves away from Great Britain, it will be snow and winter like in Siberia in Great Britain. So we hope that all the streams will be there. Possibly they will be changing. I don't know how much dramatically, but what we discovered that recent spell of the snow in March, beasts from the east. All these beasts disappeared because suddenly the wind came not from normal north or from south. It came from the east and brought us snow and cold from Siberia. So this is what will happen when the magnetic field decreases and we have some unusual patterns of formation of the flux in the water and the winds in the atmosphere. They need to be investigated before they were ignored because the model, I respect terrestrial physicists who produce nice model for the standard sun when the solar activity is standard. They work perfectly well. So they were sitting on laurels and thinking it will be working very nicely. But we now aim to the very difficult regime like if you have water and we have vapor, regime when the water become a vapor. So we need, or vice versa, water become an ice. So what is applicable to the liquid when the water is a liquid is completely opposite when the water become ice. So we need to change, adjust the models when the atmosphere comes from one phase to another. And this is what we were saying, that the phase when the ground minimum will be different. Different forces will come in power, and we need now to consider them. They were not important before, but they will become important in the next 30 years.
I watched the graph from figure 4 from your paper, and I see solar activity decreases not only in the recent cycles, but beginning with cycles 21 and going towards 26, there is a continuous decreasing. What will happen after that? The sun returns to its earlier activity?
No, the activity will be decreasing during the cycle 25, 26, and 27. And it come back to normal from cycle 28 and will be coming back as usual. So the next 3 cycles will be decreased solar activity. And after cycle 28, everything back to normal.
I saw in your paper that you quote the Sphinx mark cosmic radiations theory. Please tell us why, in the past 4 years, spaceweather.com warns us more and more about declining of the intensity of Earth's magnetic field, which thus enhances the level of cosmic particles, solar wind particles, entering our atmosphere and creating much more condensation nuclei.
Absolutely right. So we established the solar magnetic field. What we predict is a variation of solar magnetic field. What we were saying that the next 3 cycles, the solar magnetic field dramatically reduces because they come into this destructive interference. But solar magnetic field expands its wings to the whole solar system. So the solar magnetic field, it is a nice shield which protects solar system from any radiation coming from galaxy, from universe, and main radiation coming cosmic rays. So during solar activity minima, when the magnetic field is reduced, the effect of cosmic ray is increased, and they break high clouds, open our greenhouse, and cool the atmosphere. And this is why during solar minima, normally temperature is cooler on the Earth. What we are coming to the grand minimum, so this reduction of magnetic field will be even more dramatic than during the normal solar minimum. It will be very strong, I said 70%. So what it means that our shield is reduced, which means that magnetic field of the planets will take over. And it means also that cosmic rays from galaxies will be actually given a free ride, because the solar magnetic field anymore does not protect. So this is why they will come to the Earth and other planets, and they will cool off our atmosphere because they open a bit of clouds and open the atmosphere to the interplanetary space and cool off our temperature. So this is why they're warning you, because indeed magnetic field will be reduced in the next 30 years. It reduced not linearly but periodically. But during this, between the minima of activity, it will be reduced dramatically by 70%, which means that we will have a lot of strangers from galaxies breaking up our clouds and disrupting the shield which protects Earth's atmosphere from the interplanetary space. So this is correct.
Because even more, our Earth's magnetic field is declining very, very slowly, and Gary Glatzmeyer elaborated a computer model on how the Earth's magnetic field will evolve in the next thousands of years. But as the field decreases, cosmic particles will enter deeper into our atmosphere, creating even more condensation nuclei.
Mm-hmm. Well, what happened with the Earth, it's another issue.
Gary Glatzmeyer had this theory of magnetic field shifting.
Yeah, it's absolutely relevant. It is not extremely relevant towards the next 30 years when the solar activity will come. But if you heard, just remind, Milankovitch calculated the effect of different precessions of the solar and the Earth orbit around the sun. So we are not unique, we are not sitting in the isolated space. We're part of the celestial body, celestial system. So our sun is central planet, and Earth rotates around the sun and has an orbit which is nearly a round orbit with the small ellipticity. So the axis is in vertical and horizontal direction are nearly the same. Ellipticity is about 1/100th of something.
Yes,
but this ellipticity would change. This will change very dramatically effect on the temperature. Plus, our Earth is inclined. It is not sitting straight vertically on the orbit. it is inclined about 23 degrees, but inclination can be varying between 22 and 24, which will lead to further variations, will be either very cold wind and so on. So these Milankovitch cycles are very important to explain various grand minima of the terrestrial temperature. So this is nothing to do with the sun, whatever it does. It's something to do how Earth is rotated and how Earth is positioned itself towards the sun, whether it is closer to the sun, whether it is inclined to the sun, or whether it is inclined outside the sun. So these are many effects which are, and definitely people need to investigate. This is why the solar and solar terrestrial physics are very important, because this is vital for the whole humankind to understand what is expecting in the future. In future 100 years, future 1,000 years, future generations, should we start exploring other planets and take the humankind outside the planet in a few 100,000 years, because it will come another ice period when all the mammoths and dinosaurs died. So this is quite important thing.
As a journalist, I must pose some questions regarding other climate scientists that rejected your research because your findings interfere with the great man-made global warming dogma. Please tell us what happened after you published these data.
Well, not all rejected. Those who were supporting this man-made global warming, which are basically, I don't know, I would not probably express how I think, but I don't believe we have such a global warming induced by handmade. So not irrespectively what we discovered with the sun, because when we had hype of the global warming on the Earth, the same time the caps of ice on Mars were melting, and we have typhoon on Jupiter. So if it is human who induced global warming on Earth, we must be inducing the similar global warming on Mars and Jupiter, which is obviously nonsense. So therefore, I would be very reluctant to say that we have this global warming induced by humans, but nonetheless, I respect that maybe something we contribute in. And what I said to those who are rejecting our predictions, because we predict what happened in the past. So we said during Mount Minima we had reduction of the temperature, and it is well protocoled. The temperature was dropped in England by 1.2 degrees of Celsius, and it was presented in many papers by Lean et al. So we expect similar reduction of the temperature during the next grand minimum. Whether they will overwrite the predicted global warming remains to be seen. And I said, luckily, the sun put the experiment very clear. The grand minimum is upon us, so we will see within next few years or the next 30 years whether the temperature will continue to rise or it will decrease. And what is shown in this year, in 2017-18, the temperature already decreased 0.5 Celsius, which was recorded officially because there's the snows and everything. So I said, okay, we have competing theories, and only time will show who is right. So I'm happy to look what happens, and I believe the sun will have upper hand because this is the main star. And looking backwards, 5,000, we now calculated this curve to 100,000 years, and it really nicely fits the basic features reported from the Earth from this period, from paleontology and other. So obviously, Sun and Earth interaction is well established. They know each other, they know each other faults, and they respond accordingly. So I'm not so sure that the humans are so powerful to interfere between interaction of the sun and the earth. But time will show. Again, we are all in the front seat. We will see what happens in the next, starting from now, basically. I thought it will start 2020, but it started this year. And the next few years, we will see what happened at this grand minimum. And the next 20 years or 12 years, we will see what happened between cycle 25 and 26. And we will see if the temperature decreases or not. So time will show.
But there are many other scientists having same opinion with you regarding solar activity and its influence on Earth's climate.
We are not the only one who's saying there will be reduction of solar activity. There were many people in America. I know John Casey. I know other scientists. They have the whole motion called the big grand minimum. They have their own television who are exploring, they from different side of terrestrial activity, of solar activity, they all statistical analysis indicating that the solar activity is reducing and should be coming to the minimum during these cycles. They didn't predict that far as we did because they didn't have the formula, but they were seeing that the solar activity will be reducing. And they saying, yes, it will be reducing. What we basically did, we explained why this solar activity will be reducing and how. So basically, we gave them the power to understand that it is not like the sun coming to the end of its life. It is, to the contrary, sun producing endlessly, very tirelessly, all those waves with the same frequency and the same amplitude. But what is happening, these waves interfere with each other, and the visible effect is this summary wave, which I've shown you, amplitude is reduced and so on. So we've shown them that what sun does, it does tirelessly, can last for another 4.5 billion years at the predicted life of sun. But this interference of waves produces the visible effect on the solar surface and the effect of the solar activity on the Earth. So we explained this, and this gave those people who predicted reduction of activity and reduction of the temperature on the Earth, they gave them the power to understand why this would happen and how exactly this would happen.
And knowing already that this information is so profound and accurate, why the IPCC wants to stop this going to the public?
Well, I want to remind you, remember, you read in the history, what was in the medieval age, the planetary system in action? It was Ptolemy's system, when all these scientists, astronomers thought this Earth is the center of the universe, and the sun and all the planets, they rotate around the Earth. When they start calculating ephemeral movement of the planet on the sky, they discovered that the planets cannot move around there. They should move in one sphere and then jump to another sphere in order to match the motion on the sky. So this is Ptolemy's system. They thought, right, sun rotates around the Earth and planets rotate. So this is what the system enact when it was last grand minimum, Mount minimum.
Okay, but we are no longer living those times. We have an amazing science now, and still...
Asking me why, I would tell you, Copernicus came up with the idea that the sun is the center of the planet and planets rotate. And you remember it took about 50 years or 100 years to take over the brains, because people who were the power, they used priests. They didn't want the new thing come up because they had all the power, they had everything, and suddenly the power is broken out from the feet. Similar in here, those people who predicted The global warming, man-induced global warming, they got all the funding, they got everything. And suddenly, sun comes up with this, grand minimum and explain, all right, you done something wrong. It will not be minimum, it will be cooling. So they need to turn their own research and look very carefully what people suggested. And I have to say, whether they like it or not, but this minimum and this cooling will happen as it happened 400 years ago. And they had to look at it, because if temperatures reduced only in this year 0.5 Celsius, it will keep reducing, and they cannot claim that it is endlessly increases. And I'm not speaking about reduced pole caps of the Mars and Jupiter on the Earth. So definitely what is happening, people got something, some ideas, they got some funding, and they want to protect the funding. They think with only 100 years they will recognize we were wrong, but who cares? We get all the funding, all the glory, we become famous. This is fine. So the only thing they didn't count, that the sun has its own views, and sun decided, I'm fed up, I'll show them who is the boss, and sun they put grand minimum. This is it. It will become snowing outside and freezing. It will clean up the human minds. Before, in 2015, those supporters of global warming, they called Royal Astronomical Society and demanded to withdraw our press release. To the owner of the Royal Society, they said, no, it has been done and we stand by it. Speak to the author. They spoke to the author, they tried to persuade me. I said, look, I have nothing against you. You've done your job, I done my job, and let us see. It will be 5 years and we will know whether it will start cooling temperature or increasing. So I didn't want to fight with any of them, but the time will show. But the problem is that not only its scientific interest, whether it will be cooling or increasing, it is very important interest, because what we need actually think where to find the sources of the energy, how to provide heating to our residential and businesses. Because when we had cool period in March and everyone put the heating on, BBC started asking the businesses not to use heating, switch off, because our grid ran out of capacity. We don't have enough energy. If it was cold another week or so, we probably would need to stop and they would switch off periodically this heating. And this is only about heating, and only 3 weeks we had snow rise. When it will become between cycle 25 and 26, when it will be period much longer, this will be the problem. So probably we need to postpone cancelling and destroying fossil stations and use them, because they are the only one who can heat the houses and produce enough energy. And then after we pass through the grand minimum, we start replacing fossil stations with nuclear station or other, but who knows who is cleaner, because nuclear waste is much more dangerous than this evaporation which comes from fossil station. And not speaking about the food. Who will produce this food, vegetables, fruits? Who, if we don't have enough vegetables and enough wheat, your animals will not have enough food. So we will not have enough food for the nations. And this has to be tackled. It has to be anticipated, and the whole governments, they need to change. Yeah, maybe it is global warming, we need to protect the earth, it's fine. But for time being, most urgent task is actually to supply heating to houses and food to the nations. If we don't have enough food, maybe we need to protect and produce the cans of different canned food, give people, reserves and say, save the food, put the storage, because in the next few years we will be short of them, kind of thing. This is the thing which government need, many governments, not a single one, they need to change their perception. They brainwashed. Maybe there was some, global warming or something increase, but at the moment, whatever was doing that, we put in a little bit on the back seat because we have much more urgent problem, which will be decreasing the temperature, and we need to tackle it.
It is very disappointing that in the 21st century, with such an advancement of science, to continue to stay in a dogma which is not true.
At the moment, I actually working with the council about the global climate change, and they asked me to give a talk because after this cold snatch, which happened whole the northern hemisphere, many governments realized that they have to take this cold snap very seriously, and if it will keep repeating and repeating and repeating, then maybe they need to think, okay, we keep in mind, consider that the sun gives us like time, 30 years to prepare for the next global warming, because if it is global warming, in 30 years, when the sun comes back to normal, it will be even worse, isn't it? So we have 30 years to resolve our problems, reduce our pollution and everything. And at the same time, we need to provide food and heat to the population. This is the main issue for everyone.
Dear Dr. Valentina Zharkova, I thank you very much for your time and preparation in order to answer these questions. And after broadcasting on TV, a copy of this program will be uploaded on my YouTube account.
Okay, and send me the link, so I want to see it and show it to my friends.
I hope that when those times will come, you'll accept a new interview on Skype.
Let us see if it will be okay, surviving, we can do something else.
I thank you very much and meet you next year for a new interview.
Hopefully we will be healthy and wealthy. Okay, goodbye.
Bye-bye. All the best. Acesta a fost interviul îngrijorător cu matematiciana și astrofiziciana Valentina Zharkova, cercetătoare la Universitatea Northumbria din Marea Britanie, pe care l-am difuzat în 2 episoade consecutive la Știință și Cunoaștere. În completarea emisiunii o să vă ofer spre redifuzare un rezumat al celor 8 ore de interviuri cu climatologul canadian Tim Ball pentru a pune în balanță viziunea climatică cu cea din astrofizică, observând astfel identificarea punctelor comune față de care putem să trasăm reperele necesare. Fiecare dintre dumneavoastră puteți judeca singuri. Now we are entering directly into the topic of climate changes, which is a very large one. Already thousands of books were written in the last 50 years, so obviously we cannot cover the topic in 1 or even 2 hours of TV programs, but at least we should try to analyze some issues. And in our first part program, I propose to discuss about the role of the sun in climate changes.
Sure. One of the things, Chris, that it's important to understand for the listeners is that climatology, or first of all, let's separate. Weather is what you experience when you stand outside. And it's the sum total of everything from cosmic radiation in space to heat coming off the bottom of the oceans from geothermal and everything in between. So you're experiencing a total effect when you stand outside in the weather. Climate is the average of the weather. So if you record the weather on a daily or hourly basis, and then you average that out over time, that gives you the climate. And what I have focused upon is, first of all, the climate of regions, so that you've got, say, the climate of Romania or the climate of Britain, and then how climate changes through time. And that's really the important issue here. Now, one of the difficulties is that climatology is the study of the total of what creates weather and climate. And it's a generalist discipline, but we're in a world today in which everybody's a specialist. And so what you've got is a person that spends their whole life just studying CO2 or just studying one little piece of an enormously large puzzle. And we don't have the ability to put it back together again. And so what you have to distinguish in the literature and all of the research stuff is what's the general picture? What are people like me, the climatologists, saying? And then what are the climate scientists? Because you see, a climate scientist is somebody who, say, has studied physics and then has specialized in just one small part of the whole climate puzzle. And that's why there's so much confusion about what's going on. And of course, you see it. The analogy I like to use is that the patient is lying on the table, and one doctor, the specialist podiatrist, is looking at the feet. And then another specialist is looking at the kidneys, the nephrologist, and the neurosurgeon's looking at the brain. But the nurse, who's concerned about the patient, is saying, but doctors, the patient's dead. You see, and that's the difficulty that we have in today's world. And people are living in a generalized world. And so when they hear about just one piece of it, they have no context for that. And so that's why it's such a confusing issue and topic. And by the way, meteorology is one of those specializations. Meteorology is actually a study of the physics of the atmosphere, which is only one small part of the total picture. But because meteorology came out into the public arena before climatology, it's what everybody knows. So meteorologists do weather forecasts. And the weather forecasting began in the First World War once they started flying and the pilots needed good weather forecasts and so on. That's why most weather stations are at airports today. And so all of these factors have to be understood to understand why there's so much controversy over climate change and climatology.
I had recently watched a very well-organized material on YouTube about a compendium of observations regarding the sunspots, and I'd like to explain step by step those graphs, which I hope are available for public presentation.
The sunspot is a darker area on the surface of the sun. The larger ones are about the same diameter as the Earth. They appear at the equator, and then they move out towards the polar region in both directions away from the equator. And they rarely go more than 40 degrees away from the equator. They appear to be evidence of circulation of energies within the sun. They are cooler in temperature than the surface of the sun. The sun is about 6,000 degrees Celsius. The sunspots are about 4,600 degrees Celsius. But that's a contradiction because they're more important in terms of how they affect the Earth in terms of the magnetism. We've known for a long time that when there are a lot of sunspots, the Earth is warmer. When there are fewer sunspots, the Earth is colder. But we didn't know what the mechanism was. In other words, you had a correlation. This was happening, and therefore that's happening. But in science, you have to be very careful because it doesn't mean that there's a cause and effect relationship. And so it wasn't until 1991 that we started to get an understanding of what the relationship was. But Chris, if I might just for a minute to put this in a larger context, the sun is being virtually ignored in the official climate science that the United Nations are doing, the Intergovernmental Panel on Climate Change. The reason for that is that when they were charged with looking at climate change, the IPCC, the definition that they were given was only look at human causes of climate change. Well, if you do that, then it means you're not going to look at changes in the sun.
Yes.
But you can't understand what effect humans are having if you don't understand what are natural causes like the sun.
Yes.
So right? So the IPCC doesn't look at sunspots.
We are arriving later on this program, but for the moment, please talk us about the historical observations of the sunspots.
Back to the sunspot question again. Galileo was the first to see the sunspots, of course, with his telescope on the sun. And one of the heresies that Galileo was accused of was that the church and the scientific belief at that time was that everything beyond the moon was perfect. Okay? And so when you found blemishes on the sun, that raised huge religious problems, right? And it's just like with Copernicus, it wasn't so much that he said that the Earth's going around the sun that the church were upset about. What they were upset about was he said the universe is infinite. And they said, well, if it's infinite, where's heaven? So he then became political by saying, well, it's an immeasurable distance. Well, the same thing with Galileo. When Galileo pointed out that there were blemishes on the sun, the view of that time of Western religions was that that can't happen. But Galileo was the first to record the sunspots. We've got all of his notes. That occurred in 1610. Since then, they've been regularly recording the number of sunspots. And so what they noticed, a fellow by the name of Wolf noticed that they come in patterns, that there are cycles to the sunspot numbers. But so he started, yeah.
Yes, it's really amazing how clear they could actually see the sunspots with rudimentary telescopes more than 400 years ago.
Oh, exactly. And by the way, if the listeners are interested, there is a superb series called The Ascent of Man with Jacob Bronowski, who was a historian of science. And he pointed out that our knowledge and understanding of our world and our universe is determined by our technology. So once the telescope was invented, it changed our whole view of the world and the universe, and therefore ourselves. The microscope was another example. The Hubble telescope going out beyond the atmosphere. So all of these things have changed our view. But yes, you're right, for 400 years. But what Wolf did was he noticed that there were, if you counted the number of sunspots, there were definite cycles, and that the number of sunspots was minimal, and then over an 11-year cycle it increased, and then it decreased in an 11-year cycle.
Yes, we are arriving there also, but regarding this very old data about sunspots, how much of them can we integrate today in our modern interpretations?
Well, it's easy to integrate the data into the models. The problem is that it's not being done in the official government science because, as I said earlier, they said, well, we can't integrate that in because we don't know a mechanism. So if you go and read the Intergovernmental Panel on Climate Change report, they don't even mention sunspots. Now, the breakthrough came in 1991 with out of a guy by the name of Svensmark. Now, he wasn't in it right at the start, but he picked up on it since. What he realized was that the sunspots simply were visual evidence of a change in the whole mechanism of what the sun was doing, but particularly a change in the strength of the sun's magnetic field. Now, that magnetic field controlled the amount of cosmic radiation coming from space and reaching the Earth. As that cosmic radiation passes down through the atmosphere, in the lower atmosphere, it creates what are called condensation nuclei. These are small particles. Most of them are salt particles from the ocean or clay particles from the Earth. They are necessary for water vapor, that is, water as a gas, to turn into a liquid. We had known for a long time that there weren't enough condensation nuclei in the atmosphere to explain all the cloud cover we had. Now, what Svensmark did was he explained that these cosmic radiations were the missing nuclei, but the correlation between low cloud cover and the amount of cosmic radiation reaching the Earth is almost 100%. And of course, that cloud cover then acts like putting a screen or a shield in the greenhouse. It's the major short-term control of temperature of the Earth. And so that's been in the literature since 1991 and was confirmed in 2008. And yet, as I said, it's not even included in any of the government computer models or even in their literature.
Yes. And now we are coming to what you were trying to tell us earlier, the next introductory question, which is what is a solar cycle? How many types of solar cycles are? What is their duration in years? And how do they affect our climate?
Okay. There's a much longer cycle of solar activity that we'll talk about after called the Milankovitch effect. He was a Serbian mathematician. But your answer about the sun's specific activity and solar sunspot cycles, they only consider from about 1741 the cycles and the number of sunspot counts to be accurate enough to be usable. We do have them, as I said, back to 1610. But Wolf determined that taking the sunspot number counts, he found that there was an 11-year cycle, I've already mentioned, but that's the average length of the cycle. It actually varies from 9 to 13 years. So the average is 11, but its variability is 9 to 13. Then every second 11-year cycle, the polarity of the sunspots reverses, which creates a 22-year sunspot cycle. Now, one of the things that we would probably talk about a little bit later on is that 22-year sunspot cycle correlates with drought conditions in the middle latitudes. And that's something that Theodore Landscheid and I were talking about, and we're going to talk about him a bit later. So there's an 11-year cycle, a 22-year cycle, and then there's a 96-year cycle. And that's interesting because it generally tends to occur at the end of centuries. And when you look at the long-term climate record, you get quite significant climate change at the end of centuries. And then there are longer cycles than that. There's one at 150 years, and there's even cycles out to 2,500 years. How can we determine those long-term cycles of sunspot data? Well, the sunspot data correlates with energy coming from the sun, and it correlates with variations in carbon-12, which is one of the outputs of the energy of the sun. Carbon-12 is absorbed by living organisms on the surface of the Earth, including humans. In a plant, for example, it's absorbed, and it converts, after the plant dies, it converts into carbon-14. That's been used for radiocarbon dating. The carbon-14, carbon-12 ratio has been used for radiocarbon. Well, but and that was one of the first uses of tree rings by a fellow by the name of Douglas back in 1930. And he noticed that the sunspot cycles correlated with the tree ring data that he was getting. So we can extend the sunspot cycle back by using the carbon-12, carbon-14 ratio. So you've got the observation from instruments from humans, then you add that onto the evidence from other natural sources, such as the tree ring data, and you can create a very long record. That's how we're able to see these longer cycles. When you want to find out cycles within a record, you run a spectral analysis. That it's a statistical program that tells you how often there are cycles in the data. And so, for example, when I did a run on drought cycles in the Hudson Bay Company records that I had, the 22-year drought cycle showed up very, very strongly. And that was what Landscheid and I were talking about. So that's the sunspot cycles. They affect the global temperature, as I said, by varying the amount of cloud cover. And it's the low cloud cover that is important here, and it controls the temperature.
What could happen if one or more of these cycles are having manifestations at the same time?
Superimposed?
Yes.
Yeah. Okay. This is another part of the whole debate that has gone on. I'll talk about it with regard to solar cycles, but in 1991, I believe it was Warsaw, there was a climate conference at which the East and the West at that time, which of course was the communist bloc as opposed to Western science, totally disagreed. The Soviet and the Chinese climatologists have long believed that there are cycles to the climate. And all you have to do is figure out what all the cycles are and then how they interact with each other. So if one cycle is causing an increase in temperature and another cycle is causing a decrease, what's the net result, okay? The Western world at that time didn't believe in cycles at all. They believed in chaos theory. They said that the weather systems and therefore the climate systems were chaotic and that there were no cycles. It's interesting because the Russian view about climate cycles came from the economic sector because a Russian by the name of Kondratiev noticed that there was a cycle of droughts that affected grain production, which therefore affected stock markets. That K cycle is still followed by a lot of economists. And in fact, most of the research into cyclical patterns of weather particularly is being done in the stock market. There are people that follow the cycle strictly. The difficulty, now, the media and the political people interpreted the disagreement between the communist bloc and the Western world as a political disagreement, but it wasn't. It was a fundamental scientific disagreement. I happen to, having worked with Russian climatologists like Borisenkov and with Chinese climatologists, I happen to believe, and looking at my own records, I very firmly believe that there are all sorts of cycles going on of different lengths and different intensities, and that they all are interrelating with each other. And if you could sort out what the major ones are, you then have a better chance of predicting what's going to happen. But again, it comes back to how good your records are and how long your records are. So for example, if you've only got 100 years of instrumental temperature data, then any record that is, say, even a 50-year record, you're only going to have one cycle in it. So you really can't draw any conclusions. So this is part of the philosophical debate and the scientific conflict, and sorting out one cycle from another is extremely difficult with the present knowledge.
We are now approaching the recent times, and please tell us what happened with the sunspots in the last 3 sun cycles numbered 22, 23, and 24. We are now in the 24.
And we're now in 24. Yes, the sunspot cycles had been increasing in numbers. That is, the number of sunspots had increased up till the end of the 20th century, so close to the year 2000. Now, that correlates with a longer record by Uroskin showing that the sun had been increasing in activity for the last 1,000 years. And but since 2000, the sunspots numbers have decreased significantly. And cycle 22 and 23 were quite high sunspot numbers. Then 24 dropped down to a half of what 23 was. And now 25 is showing itself to be very low sunspot numbers. That is correlating with the global cooling that has been going on. Because despite all of their efforts, the temperatures are showing the Earth has been cooling down since 2000. And in fact, it's leveled off and there's a slight decline occurring. That's why a lot of the scientists like myself and some of the Russian scientists and Chinese scientists are saying that we're into a cooler period. Now, the number of sunspots in cycle 24 was comparable to the number of sunspots around 1800 to 1820. At that time, we had a minimum of sunspot numbers called the Dalton minimum, and that was a much cooler time period.
I have a question that puzzled me for a long time. If the sun activity slowed down between those minimums, why the climate had not been severely affected? Because from what I understood, the past cooling periods, the Dalton and Maunder, were present only when the sun had been on the minimum several cycles in a row, not just one cycle.
Well, that's right. I mean, the Maunder minimum, where you had a period of about 70 years where there was virtually no sunspots. And of course, that correlates climatically with a period called the Little Ice Age. So from about 1610 to 1680, with actually the coldest period around 1680, sunspot numbers were extremely low. The irony of that, of course, by the way, is that happened to cover the lifespan of the astronomer. Names just flipped out of my head right now, but he said he knew about sunspots because he'd read Galileo's literature, but he'd never been able to witness them or see them. Now, the other thing, by the way, is that in Central and Northern Europe and Central and Northern Canada, another thing that correlates with sunspot numbers is the appearance of the aurora borealis, the northern lights, because that's also related to changes in the energy output from the sun. So during the Little Ice Age or the Maunder minimum, there were virtually no aurora seen. And so this scientist whose life covered that span wrote an article in which he thanked God for living long enough to be able to travel up to Scotland and witness the aurora. But the minimums correlate with much colder temperatures. And the Little Ice Age, as I said, correlates with the Maunder minimum. The Dalton minimum, where you had very, very cold weather conditions around the world. Now, the Dalton minimum was a little bit difficult because almost in the middle of that, actually slightly towards the end of it, in 1815, I should say, there was a massive volcanic eruption in Indonesia called Tambora. And it put up so much dust that it cooled the Earth down by 1 degree Celsius. But the Earth was already cold at that time. So there's another example of cycles on cycles. But the correlation of cold weather with low sunspot numbers is very well documented.
Please tell us if we had severe climate on the period of solar cycle 14, year 1907, which is similar to what we have now, and if there is any probability that we might have colder winters in the next few years.
Yes, one of the things that people, the focus that I mentioned has been on temperature, and it's been on annual temperature. But if you just take seasonal, you can see that the summer temperatures haven't changed very much over time. All of the change has been in winter temperatures. So what's been happening is the winter temperatures have got higher. It's milder in the winter. And now the winters are getting colder again. And you're seeing that. And that's one of the first things that made the public start to raise questions. Say, well, we got this brutally cold winter. You can see it now across North America, record cold temperatures. The reason for this, Chris, is that as the Earth cools down, the way that the whole global weather system works is you think about the Earth and then you think about the atmosphere around it. There's basically two air masses. There is a dome of cold air over the polar regions, one over the South Pole and one over the North Pole. In between is warmer tropical air. Where those two air masses meet is called the polar front, okay? And in the atmosphere above that polar front, that's where the jet stream blows. The jet stream wanders back and forth, and the polar front, there are waves in the polar front that wander back and forth. Now, as that dome expands, that creates the colder winters. but it also it creates increased variability of weather. So the jet stream waves, instead of being fairly low like that, they start to go well north-south like that. The farmers are aware of it because they see changes in the wind directions, but what you also see is increased variability of temperature. That's why now you're seeing record high temperatures, but also record low temperatures. But over time, the jet stream will level out, and it will be overall cooler in that dome. And so we've seen this before, and that's the pattern. Some people are predicting, as I said, the sunspot number cycle to continue to decrease until at least 2040. Some people are giving longer predictions. They think this cooling trend is going to go for 500 to 600 years. Certainly when you look at the 300-year cycle of global temperature, that's certainly possible. But there is no doubt that the world is cooling down and will continue to cool down based on the basic evidence that we have.
This is very scaring, because on this winter we had only 3 days when temperature fall down below the normal range of the month, and in some regions had been recorded minus 34 degrees Celsius, and that was called a record of the coldest days in the last 50 years. Fortunately for us, the unusual cold lasted only 3 days.
Okay, what I was talking about was that one of the IPCC members who's studying Antarctic ice has come out and said that he still believes that CO2 and warming is going to occur, but what he's saying is that the cooler times are much worse for the planet and for people and plants than warmer times. And this is one of the things I've been talking about. All of the focus is on warming and how bad that's going to be. But as you've just said about Romania, a colder world, even a slightly colder world, is a much, much greater threat. And you see this, for example, they've said, oh, with warming, there's a lot more people are going to die. But every year, more people die of the cold than of warm, even in these warm years. And so the government planning only for warming is so silly. What they should do is plan for cooling, because the adjustment to warming is a lot easier than the adjustment to cooling. And by planning for warming, you're making yourself unprepared for the cooling that's coming. You see that in the energy policies that are going on.
În concluzie, eu cred că toți climatologii, atât cei pro cât și cei contra încălzirii globale, determinate exclusiv de activitatea omului, ar trebui să colaboreze cu astrofizicienii și cei care studiază fizica Soarelui pentru a ajunge la modele matematice mai bune, la rezultate mai aproape de adevărul climatic, ce are milioane de variabile, pentru că e în folosul nostru al tuturor. Fiți alături de noi data viitoare la o nouă întâlnire cu emisiunea Știință și Cunoaștere.